For 4.5 billion years, our solar system has been a closed ecosystem, a clockwork mechanism of planets, moons, and asteroids, all born from the same dust, all moving in the same flat plane, all obeying the same traffic laws of the sun's gravity. We thought we were alone in our little bubble. We thought the void between the stars was too vast, too empty, and too dead for anything to cross it. We were wrong. On October 19, 2017, the Pan-STARRS telescope in Hawaii detected an anomaly. It wasn't a rock, it wasn't a comet, it was a visitor. They named it Oumuamua. In Hawaiian, it means a messenger from afar arriving first, a poetic name for a terrifying reality. This object was traveling at 196,000 miles per hour. At that speed, the sun's gravity couldn't hold it. It punched a hole through our solar system, diving past Earth at a distance of just 15 million miles, and then vanished back into the blackness. But in the brief window we had to observe it, Oumuamua broke every rule of astrophysics. It had the wrong shape, it had the wrong orbit, and most terrifying of all, it had the wrong acceleration. This is Dark Sector X. Today, we are reopening the file on the single greatest mystery in the history of astronomy. We will strip away the natural object cover-up and look at the mathematical impossibilities that suggest this was not a rock, but a probe. We will explain why its tumbling motion was a calculated scan and address the chilling possibility that it wasn't just passing through, it was waking up. To understand why Oumuamua terrified the scientific community, we first have to talk about geometry. We never actually took a photograph of the object. It was too small and too fast. All we had was a light curve, the measurement of how its brightness changed as it spun. Every 8 hours, the object's brightness would drop by a factor of 10. In the natural world, asteroids are potato-shaped. When they spin, their brightness changes slightly, maybe a factor of 2. A factor of 10 is mathematically impossible for a standard asteroid. It implies an extreme aspect ratio. Calculations revealed that Oumuamua was at least 10 times longer than it was wide. Imagine a football field, but compressed into a thin metallic needle, or a pancake. Nature does not create perfect cylinders. Nature creates spheres. Gravity pulls matter into balls. Erosion rounds off edges. For a rock to naturally form into a splinter shape like this, it would have to undergo a specific, highly unlikely type of collision billions of years ago. But the strangeness doesn't stop at the shape. It's the texture. Spectroscopic analysis suggested the surface was dark red. In the cosmos, this color usually indicates tholins, organic compounds that have been baked by cosmic radiation for millions of years. This suggests that Oumuamua has been drifting in the interstellar void for a very, very long time. But here is the detail that was buried in the footnotes of the reports. The data indicated that despite being bombarded by the sun's heat at perihelion, where temperatures reached over 500 degrees Fahrenheit, the object did not disintegrate. It held its structural integrity perfectly. Standard ice would have boiled instantly. Standard rock would have cracked from thermal shock. This suggests the outer layer was not just a surface, it was a shield, a hardened crust designed to protect something inside from the harsh radiation of deep space. We will discuss what might be hiding inside that shell later, but first, we have to talk about the movement that defied the laws of Isaac Newton. In June 2018, months after the object had disappeared, a team of astronomers led by Marco Micheli published a paper that dropped a bombshell. Oumuamua had accelerated. As it moved away from the sun, it picked up speed. Now, in the vacuum of space, objects only speed up for 2 reasons. Reason 1, gravity. If it passes near a large planet, it can steal some momentum. This is called a gravity assist. But Oumuamua didn't pass near any planets. Reason 2, outgassing. This is the comet theory. When a comet warms up, ice turns to gas. This gas shoots out in jets, acting like a natural rocket thruster. This is called the rocket effect. It seemed like a logical explanation until you look at the data. Oumuamua had no tail. The Spitzer telescope looked for heat from carbon dioxide gas. It found nothing. Deep space radio telescopes looked for water vapor. They found nothing. If there was no gas, there was no rocket effect. So we have an object that is shaped like a needle, tumbling in a controlled manner, accelerating away from the sun with no visible propulsion system. According to Avi Loeb, the former chair of astronomy at Harvard University, there is only one explanation left. It wasn't pushed by gas, it was pushed by light. Solar radiation pressure. Photons from the sun have no mass, but they have momentum. When they bounce off a reflective surface, they impart a tiny, tiny push. For this push to account for Oumuamua's acceleration, the object would have to be incredibly thin, not a solid rock, but a membrane, a sail, less than 1 millimeter thick. Nature does not build solar sails. If this theory holds water, then Oumuamua wasn't an asteroid. It was a piece of defunct technology, interstellar flotsam, or a buoy. This leads to the most disturbing hypothesis of all, the local standard of rest theory. Most people think Oumuamua flew into our solar system. That is technically incorrect. From a galactic perspective, Oumuamua was sitting still. It was at rest relative to the local standard of rest, the average motion of all the stars in our neighborhood. It was like a buoy floating on a calm ocean. It was our solar system that rammed into it. We were the ones speeding through the galaxy, and we hit this object like a bug hitting a windshield. Statistically, the chances of finding a rock sitting perfectly still in the galactic rest frame are billions to 1. It is a very specific parking spot. You only park something there if you want it to be found, or if you want it to monitor traffic. Let's reconsider the tumbling motion. If this was a probe, why was it tumbling chaotically? In surveillance, you don't want a fixed camera. You want a 360-degree view. By tumbling, Oumuamua could scan every direction of the solar system as it passed through. It saw the gas giants, it saw the asteroid belt, and for a brief few days, its sensors would have swept across the third rock from the Earth. It would have detected our radio waves, our television broadcasts, our radar. We have been leaking noise into space for 100 years. Oumuamua was the first thing to get close enough to listen. The Breakthrough Listen project pointed their radio telescopes at the object, hoping to catch a transmission. They heard nothing. But in the world of intelligence gathering, silence is standard protocol. You don't broadcast while you are deep in enemy territory. You collect data, you store it, and you transmit it only when you are safe in the dark, far from the target. Oumuamua accelerated after it passed Earth. It used our sun as a gravity slingshot to boost its speed for the long journey home. So let's answer the open loop. What was inside that shielded crust? If Avi Loeb is right, it wasn't a biological crew. It was an AI, a dormant algorithm wrapped in a solar sail, drifting for millions of years, waiting for a star system to wake it up. It entered our house, it counted our planets, it tasted our solar wind, and it felt the radio waves of our civilization. And then it decided we weren't worth stopping for. Or perhaps it decided we were a threat worth reporting. The scary part isn't that aliens are coming. The scary part is that the scout has already come and gone. And now, somewhere in the deep darkness of the Lyra constellation, something is receiving the data. The universe is full of ghosts. Oumuamua was just the first one we saw. If you want to know what else is watching us from the void, subscribe to Dark Sector X. We are watching the sky.